Okay guys, today we're going to start our chapter on exponents. Now the first thing that we're going to talk about is what happens when you have a negative exponent. Now, negative exponents aren't something that we are allowed to have. Negative exponents are something that we want to get rid of. So, on number 1, if you'll notice, we have x raised to the negative second power. Now, right now, this is considered a fraction because we can put it over 1. So that's really x to the negative second power over 1. When you have a negative exponent, all you have to do to get rid of it is move the term from wherever it's at in the fraction to the other part of the fraction. So currently, this is in the numerator. We want to move it to the denominator. So I'm going to start by making a fraction bar. And when I move this x to the negative second to the denominator, it becomes an x to the positive second. But we need to figure out what goes up here in the numerator. So since there was nothing else up here with that x to the negative second, we're going to just have 1. So x to the negative second is really just 1 over x to the positive second. So again on number 2, I have y to the negative fifth, and remember that's really like saying that's over 1. That's like a fraction. To get rid of that negative exponent, I want to move this guy to the denominator, and my exponent will then become positive. So now if I move it to the denominator, it's going to be y to the positive fifth. And then since there wasn't anything else, this coefficient is technically a 1, that's going to stay a 1. So y to the negative fifth is really just 1 over y to the fifth. On number 3, I have 1 over a to the negative third. Notice I have a negative exponent, so we can't have that. I want to move it to the other part of the fraction. So now I need to move it to the numerator. So if I move a to the negative third to the numerator, then it'll become a to the positive third. Now remember, this is still in a fraction, so I need to see what's going to be left in the denominator down here. Well, the coefficient was a 1, so that's what's going to be left. Then we can simplify that to just a to the positive third. So really what this is saying is when it's a negative, it has to go. It has to move. So should it stay or should it go? If it's a negative exponent, it has to go. Go to the denominator, go to the denominator, go to the numerator. Now on number 4, I have 2 over b to the negative second. Now this 2 has no exponent. That means it's just going to stay put in that numerator. Okay? The b to the negative second is what's giving us problems. That's in the denominator, so I need to move it up here to the numerator with the 2. So when I move it to the numerator, it becomes 2 times b to the positive second, and the coefficient of this variable stays put. That's a 1, which means that this can simplify to 2b squared. Now on number 5, we have a lot of different things going on. You just have to remember, these are all like fractions. We can say this is one big fraction because it could all be over 1. So we just have to see if we need to keep the term where it's at or move it to go somewhere else. So on my first guy right here, x to the third, that is already a positive exponent. We don't have to move that. So if I start my fraction bar down here, x to the positive third can stay put in the numerator. Nothing's wrong with x to the positive third. Then, if I look at y to the negative fifth, that's a negative exponent, and I don't want that. So that guy needs to move down to the denominator, and it's going to become y to the positive fifth. Then I can look at my third term, z to the negative eighth. We have a negative exponent, so it needs to move down to the denominator to become z to the positive eighth. Now don't forget to cross your z's, because we're going to have a lot of z's and 2's this chapter. Let's try it again on number 6. Remember, this is like one big fraction, and we're going to look at each one individually. So if I start with p, p doesn't have an exponent, which really means that it has an exponent of 1. That's like saying p to the first. Well, that 1 is positive, so it can stay put. It can still say the p in the numerator. Now my second term, this q to the negative second, it's negative, so it needs to go to the denominator, and so that'll be q to the positive second. And then my third guy here, r to the negative third. It's got a negative exponent, so it's going to go to the denominator and become r to the positive third. On number 7, we don't have any variables. We only have a number, but that's okay. If you'll notice, this number, 12, has an exponent and it's negative. Now here's what you should not do. A lot of us will automatically get our calculator and we'll say, okay, 12 to the negative second, and oh man, we get a gross decimal. That can't happen. We all know that I don't like decimals. So what we need to do is we need to set this up as a fraction. This is 12 to the negative second over 1. Then we need to say, okay, since this is a negative exponent, it needs to come down here to the denominator. So 12 now is to the positive second in the denominator. Now what was left up here is just a 1. So I have 1 over 12 squared. Well, now we can definitely simplify this because I know that 12 squared, if you need to use your calculator, that's fine, but this should be one of those perfect squares that you know. 12 squared is 144. So exactly my answer should be 1 over 144. Now on number 8, it's a little bit different. I have a fraction, and notice it's in parentheses, and the whole thing is being raised to the negative second power. Now, I cannot make this guy a fraction like I did on number 7. I can't put this all over 1 because you can't have a fraction inside of a fraction. So let's talk about what this really means. If I were to talk about 3 over 7 to the negative second, that's really saying like I'm taking my numerator to the negative second and my denominator to the negative second, which would really mean 3 to the negative second over 7 to the negative second. Well, I have 2 negative exponents now, which is not okay. So if I were to change that up and fix it, this guy, since it's negative and in the numerator, would have to go to the denominator and become 3 to the positive second. This guy, since it's negative and in the denominator, would have to go to the numerator and become 7 to the positive second. Well, this guy I can now simplify. But if we notice, it's really saying 7 squared over 3 squared, which is kind of like the reciprocal of this guy. So to make this a little simpler, whenever you have a fraction in parentheses being raised to a negative exponent, you can just reciprocate that fraction and make it a positive 7 over 3, and then your exponent can become positive. Now I can do this in my head. 7 squared is going to give me 49, and 3 squared is going to give me 9. So 3 over 7 to the negative second is the same thing as 7 over 3 to the positive second, which gives me 49 over 9. Well, let's try it again on number 9. I have 4 over 3 to the negative fourth. Since the entire fraction is being raised to a negative exponent, we need to reciprocate it. That means I'm going to have 3 over 4 to the positive fourth. Well, that means I want to take my numerator to that exponent, so 3 to the fourth, and my denominator to that exponent, 4 to the fourth. Now, 3 to the fourth might be a little difficult to do in our heads. Not a big deal. We have a calculator. Let's put 3 in parentheses. Well, that's not what I wanted. Let's put 3 in parentheses and raise it to the 4th power. And we're going to get 81. Now, let's do the same thing with 4. I'm going to raise that to the 4th power, and I'll get 256. Now, since my original fraction of 3 over 4 could not be simplified, and I raised them both to the same exponent, my final answer also cannot be simplified, so I don't have to worry about that. On number 10, I have r to the third over 11s to the negative third. We're going to take this one guy at a time, so we're going to start with my fraction bar. In my numerator, I just have r to the third. Now that guy has a positive exponent, so I can leave it where it's at. It's okay in the numerator. In the denominator, I have 11s to the negative third. Now, yes, this is one term, but we are going to treat it as two different things here. I want to look at just the coefficient to begin with. If I look at just the coefficient, which is 11, the coefficient is not being raised to an exponent like it was over here. If you'll notice, it is just 11, not 11 to the negative 1, not 11 to the negative 7, not 11 squared. The 11 has no exponent that is attached to it, so it is okay where it's at. It can stay in the denominator. The variable, however, this s to the negative third, is what has the negative exponent. So the variable needs to be moved to the numerator. The coefficient stays, but the variable needs to go. And when it moves to the numerator, it becomes s to the positive third. So my final answer should be r to the third times s to the third over 11. On number 11, I have 1 over the quantity of m to the fourth, n to the third, all to the negative 1. Now, when you have an entire quantity being raised to the negative first power, you're going to treat this all with the negative exponent. I'm going to move the whole thing up to the numerator. So if I have my fraction bar here, and I'm moving this whole thing to the numerator, that means I'm going to have the quantity of m to the fourth, n to the third, and now that exponent becomes a positive 1. Now anything to the first power is just itself, like 2 to the first power is just 2, x to the first power is just x. So we can simplify that in just a minute. Let's talk about what's now in the denominator. The coefficient here was just 1, so now I'm just left with a 1. Now to simplify this, m to the fourth, n to the third. This whole thing's to the first power, which doesn't change anything. So that's going to leave me with m to the fourth, n to the third, and then over 1, which really just means it's this guy right here. On number 12, I have 2a to the negative fourth, and remember this is like a fraction, over 1. The coefficient is kind of by itself. It's not being raised to the negative fourth. If it were being raised to the negative fourth, it would look like this guy right here, okay? But it does not have parentheses around it, so the coefficient is by itself. And since the coefficient does not have a variable, it stays in the numerator. Now, a to the negative fourth is what does have the negative variable, so negative exponent, excuse me, so it's going to come down here to the denominator, and it's going to become a to the positive fourth. So I have 2 over a to the positive fourth. On 13, I have 1 over 3x to the negative second. So I'm going to draw my fraction bar here. The 1 can stay put. The 3 does not have a negative exponent, so it's going to stay put. And this x to the negative second, that's what is negative, so that's what's going to move and become x to the positive second over 3. Now, if you wrote 1x to the positive, or 1x squared over 3, that's totally okay. That's definitely fine. I just simplified. On number 14, what I'd like you to do is pause the video and try it on your own. Alright, hopefully what you got is y to the 6th over 1, which is really just y to the 6th. On number 15, it looks a lot like number 14, but instead of a variable, we have a number. So we're going to treat it just like the variable at first, and then we can put it in our calculator or do it in our head. So since it is in the denominator with a negative exponent, I'm going to move it to the numerator to become positive. So it's going to be 5 to the positive second, and then we're just going to be left with 1 down here. Well, 5 squared is just 25, divided by 1 is just 25.